All right, so at this point, Miss Stedman, if you could get the group into their partners, they should be taking their quick quiz on 7.1. They should be whisper voices and spread out throughout the room so that they can work quietly. If you could give them about 15 minutes, no more than 15 minutes, that should be enough to get them through. If they need a little bit more time, they can take a little bit more if it looks like the whole group is not done. All right. Otherwise, when the quiz is over, I'm going to need you to pause the video. All right, so at this point, I'm hoping your quiz is over. You should have done a homework check real quickly for number 2. You can do that in your group. If you haven't done that already, go ahead and press pause. And now we should be on 7.2, day 2. All right, so in this case, I'm just going to do one quick free response question. It is going to be kind of random, not really having to do much with what we're doing, but just a practice problem. I thought it was interesting because it uses a few different functions, and I thought the wording itself is also a little bit confusing, which makes me want to do the problem. So, looking at the question, it is question 4, which means it is a non-calculator question. All right, let's start with reading the question. The rate in calories per minute at which a person is using an exercise machine burns calories is modeled by the function f. F of t is given for 0 to 4. So what's interesting is there is a polynomial function given just for this piece, and then the rest of it is piecewise linear. All right, good to know. Let's start with a f prime of 22. So at 22, that would be here. This is the graph of f. Therefore, to find f prime, I would be finding the slope, or the derivative. In this case, because it's linear, you're literally going to find the slope between those 2 points. The slope between the 2 points is going to be the same as the slope at that middle point at 22. So, slope would be, take the y value of one of the points, I'm taking the top point first, minus the y value of the second point, divided by the x value of the first point, minus the x value of the second point. And in this case, I get 12 over negative 4, negative 3. The second thing they ask you for is indicate units of measure. So I'm going to actually rewrite the derivative in different notation. I think this notation is a lot easier to find the units. The f function is calories per minute. The time function is obviously minutes, so that's the same as calories per minute multiplied by 1 over minute. That's how we can multiply by this. And we get calories per minute squared. All right, so that's part A. Let's look at part B. I think part B is always a little bit confusing. Part B says, for the time interval from 0 to 24, at what time t is f increasing at its greatest rate? So not only do we know it's increasing, we want the increasing to be the greatest rate. Well, f increasing, that's the function, and we want its greatest. So that's how I can tell I'm supposed to maximize f prime, which is very interesting. If you're trying to maximize a function, remember, to maximize a function, you take whoever's function you're trying to maximize, take its derivative, set it equal to 0, set it equal to undefined, and you'll end up doing a sign chart for it. And in this case, we're going from 0 to 24. But what's interesting is 0 to 24, you actually have 2 functions to deal with. One function only goes to 4, and that's the polynomial that's given up top, right here. From 4 to 24, we're talking about the function has to increase. Well, there's only one place that the function increases. So I'm actually going to find the f prime of this purple line, and we do that by finding the y value of the top point minus the y value of the bottom point, x value minus x value. So we end up with 6 over 4, so I get 3/2. So that's the f prime value for that purple line. Now I want to find the maximum, so I just have to double check if this nice little curvy part has an f prime value that's going to be bigger than that. But I already have the frame of what I'm going to do, I just have to physically do it now. Meaning, I know I'm going to need f double prime. So let's start with f prime. That would be negative 3/4 t squared plus 3t. Therefore, f double prime would be negative 3, I believe, halves t plus 3. Set that equal to 0. F double prime will not equal undefined because it's polynomial. We get that negative 3 halves t is equal to negative 3 multiplied by negative 2/3, which will cancel this guy. Then I know negative 3 and negative 3 will cancel to be 1, and t is equal to 2. So at t equal to 2, I know my second derivative is 0 because that's what I solved for. If you want to go and double check, we can double check that this is even going to be a maximum by substituting in the value 1 into the second derivative, which is right here. And if I substitute in the value 1, we end up with a positive value, but if I substitute in 3, we get a negative value. So you're guaranteed that this is a max. It actually wouldn't have even mattered because in the end, we're just going to compare values. We want to find the maximum f prime number. Therefore, to find that, I would have to find the f prime number at 2 because we already know that the f prime number somewhere between 12 to 16, that whole entire time from, this is totally bad notation, but I'm just going to do that real quick, is 3 halves. So f prime of 2, well, we found f prime right here. And if I substitute in 2, I'm going to do that off to the side right here. Sorry, this is getting messy. Negative 3/4 times 4, which is negative 3, plus 3 times 4, which is, 3 times 2, which is 6, and you get positive 2. Just kidding, positive 3. Checking if you're awake. Therefore, at 2, the time equal to 2, the f prime value is 3, and that is the maximum. All right, letter C. Find the total number of calories burned over this time. So, letter C, total number of calories. First of all, let's talk about f of t. F of t was calories per minute. Well, now they want calories, and the only way I could get just calories is multiplying by minutes. So that tells me that I'd have to take the integral of f of t times dt to make that work. So I want the integral from 6 all the way until 18, which is here. So we're not even integrating that polynomial. You're doing an integral given a graph. So we look at net signed area. So if I want to do the net signed area, I would probably do a big old rectangle, a triangle, and another rectangle. That would be what I would do. So this rectangle, starting from 6 until 18, has a width of 12 and a height of 9. So that would be 90 plus 18, so 108, hopefully. I would get the net signed area of this triangle right here. 1/2, the base. How wide is it? It goes from 12 until 16, so that's 4. How high is it? It goes from 9 to 15, which is 6. So 2, that's 12. And then this piece right here is a rectangle whose width goes from 16 to 18, 2. And a height going from 9 to 15, just like before, is 6. That would be 12. So my integral from 6 to 18 would be 108 plus 24. So 132. And it looks like total number of calories. They don't ask for units. There we go. All done. All right. Letter D says, well, now we're changing the setting to f of t plus c calories per minute. So that's the new function we're going to have to deal with. For this setting, and it's in calories per minute, find c so that the average of 15 calories per minute. All right, so I see the word average. Right now I'm thinking either slope or integral, okay? Because I can see that it says calories per minute and this says calorie per minute, they are the same function. It means I'm going to use an average value. So the average value of f of t would be 1 over, I want to find it from 18 to 6, integral from 6 to 18 of f of t plus c. Now, from 6 to 18, you want to make sure you don't reuse this function up top, because that's from 0 to 4. What I want you to notice is we actually did part of the question already. This is 1/12 integral from 6 to 18 of f of t. We just found that. what I can do is say, leaving the 1/12 out front, I'm going to separate this function c dt. Therefore, they want us to solve for c so that my average value is 15. There you go. There's the equation we're going to have to solve. So let's move that over. Try to get that. All right, so I'm going to have to solve this. So I get 1/12 times, and I can't remember what what my setting, so 132, God, I hope that value is right. Miss Sedman, if the value is wrong, please correct me. I have a tendency to make dumb mistakes. Plus, well, this c value, I'm going to find the antiderivative, which would be c multiplied by t. F of 10 would be 10c. F of 6 would be 6c, and that's actually a 16, isn't it? 6 to 16? No. 6 to 18. That's supposed to be an 18, and that's supposed to be an 18. All right, that makes more sense. And then antiderivative evaluated gives us 12c. All right, so 12c equals 15. Therefore, I would do 132 plus 12c is equal to, that's supposed to be a 12, I believe, which would then make this not 30. Makes that, 180. Man, I hope I got this right. Miss Sedman, just pause me and fix it if I get it wrong. 48, C ends up equaling 4. So again, not a problem that you've seen, not one that you're used to, but the wording, the units, all of that stuff that we've been practicing kind of gets used in here. So today, the rest of the time is for you to work on homework. And I believe, can't remember what day today is. Today's Wednesday, so you have another quick quiz on 7.2 on Friday with your partners. There you go.